Okay, folks, this is example C in the notes, question number 1, and it's going to be our first example of what we have to deal with when we have first a system without as many pivot columns as we have variables. Notice this has 3 variables. We're going to find this only has 2 pivot columns. And how then do we deal with what are called the free variables that result from that? So you're going to stick with the algorithm just as before. We'll find something interesting happens along the way. So our coefficient matrix then would be 3, 6, minus 15, 1, 2, minus 1, minus 1, 2, 4, minus 2, minus 2. There's our augmentation bar. Okay. Now, again, when I give you these problems, I intend for you to just start with the algorithm. It is possible to swap these 2 rows, and maybe something interesting will happen here, which is great. But even if you can do that, I prefer you to start with what I give you as the first equation and get a 1 in that position if it's possible to do so. So we're going to go ahead and say that our new row 1 is equal to 1/3 our old row 1, and that will give us a 1 in that pivot position. That gives us 1, 2, minus 2, minus 5, 1, 2, minus 1, minus 1, 2, 4, minus 2, minus 2. Now, that was our first pivot position here, and we got a 1 in that pivot position. So what's the next step of the algorithm? The next step of the algorithm is to get zeros above and below that pivot position. So we want zeros in this case below. So let's see here. We want a 0 here, so we're going to say our new row 2 is negative row 1 added to row 2. And our new row 3, I want a 0 here, so we're going to take and say that's negative 2 times our old row 1 added to our old row 3. Again, remember, we only ever, in this algorithm, we only ever multiply our pivot row by the opposite sign coefficient and then add down. There are other ways to do this, but this is how I'd like you to do it. So let's see here. Recopying our pivot row gives us 1, 2, minus 2, minus 5. And then when we multiply the pivot row by negative 1 and add to this row, we end up with 0, 0, that would be positive 2, that would be a 1. Negative 1 times negative 5 is positive 5, added to negative 1 is 4. And when we do, for row 3, we multiply our pivot row by a negative 2 and add down, that gives us 0, that gives us 0, that gives us positive 2. And when we multiply negative 5 by negative 2, that's negative 10, added to negative, excuse me, that's positive 10, added to negative 2 gives us a positive 8. Now, normally where do we look for our next pivot column? Well, for our next pivot column, we first try the next column immediately to the left of our previous pivot column, and we look for there to be a row with non-zero entries in what could be that pivot column. When we look at what happened here, this was our pivot column from before, and so we're now looking for, in this column, we're looking for some non-zero entries, and we don't have any. If we did have one, let's say this entry right here was a 5 or something, I could then swap those 2 rows and then continue as before. But notice in this case, both remaining rows have zeros in what I would think would be the next pivot column. And so this cannot be a pivot column. That's really important here. Y is not a pivot column. Remember, I said y because this corresponds to the variable y versus this is x versus this is c. So y does not have a pivot column. So now I move over and see if I can get a pivot column in z. And sure enough, I've got both these entries in the next potential pivot column have non-zero values, so we can go ahead and move on from there. So let's go ahead, and this will then be our next pivot position here. So notice we had a pivot position in the first column. We got a 1 there and zeros below it. We could not get a pivot position in the second column. So we moved on to the third column, and we've now got a pivot position there, and in this case it happens to already have a 1. If it didn't, we would divide the row by whatever that coefficient was, and then we'd continue on. So now I want to get zeros above and below this. So to get zeros above and below, we're going to say that our new row 1 is equal to 2 times row 2 added to row 1, and our new row 3 is equal to negative 2 times our row 2 added to row 1. And so copying over our pivot row and then doing those steps, we end up with 0, 0, 0, 0. When I multiply this pivot row by negative 2 and combine it to this row, I get a row of all zeros in my new row 3. When I do that up here, we end up with 1, 2, 0. This would be this would be positive 8 added to negative 5, which is 3. So in this case, at the end of the day, when we're done with our matrix row reduction, our Gaussian elimination row operation, notice that we had 3 variables to start with. We have 3 variables, we still do, but we only have 2 pivot columns. Which means that one of the variables did not have a pivot column. Okay. So in this case, we're going to say y is a free variable. So there are 2 ways to talk about the solution to this equation. I'm going to do it first as an ordered triplet. Okay. So normally we'd read this equation right here and we'd say, okay, well that tells me that z is equal to 4. And if I read this equation right here, it says x plus 2y is equal to 3. That's this first equation here. Right? Well, if I solve this for x, we'd have x is equal to 3 minus 2y. But I don't have an equation, notice I don't have an equation that just has a y expression in it. Okay? So when we say y is free, let's just go ahead and pick an arbitrary letter to represent whatever value y takes on. So let's let y equal, I don't know, usually I'm going to pick r. That's what our textbook does for the first one. It doesn't matter what letter we pick. So that makes our solution, the ordered triplet, 3 minus 2r, comma r, that's the choice for the y variable, comma 4. There's the ordered triplet. Okay. Another way we could represent this is to say, well, okay, for our solution that should be the vector x, y, z, we could write this as 3 minus 2r, that's a mistake. 3 minus 2r for the first row. Y we said is r, and z we said is 4. And now what I'm going to do is I'm going to break this up as x, y, z, and I'm going to break this vector into a sum of vectors. I'm going to write it as the vector 3, 0, 4. Notice that I've got all the coefficients that don't have r's in them, plus r times negative 2, 1, 0. So one thing I encourage you to do is spend a minute considering why this expression right here is the same as this, which is the same as writing it as this ordered triplet. Okay? Notice that y would be 0 plus 1r, so y is just r. Z would be 4 plus 0r, so z is just 4. And x we have as 3 plus negative 2r, which is what we have up here. So this is a way to represent the solution to this system. This is the first example where we have infinitely many solutions with one arbitrary variable. Meaning, for whatever number I pick, for whatever real number I pick for r, let's say we pick r as 1, we could come up with a solution to the system. Or let's say I pick r as minus 25. We plug in minus 25 for r, and we could come up with a solution to this system. Any one of those would work. But I had one choice of arbitrary variables. We only had one of these, and here's how we figure this out. We had 3 variables. We had 2 pivot columns, so the remaining column corresponds to a free variable. So we had one free or one arbitrary variable. You're going to get some more practice on this. After you've mastered the row reduction algorithm, which at this point you should be feeling a little more comfortable with it, after you've mastered this row reduction algorithm, figuring out how to represent the solutions in terms of arbitrary variables and how many arbitrary variables you'll have in the solutions, is the most important takeaway from this Gaussian elimination procedure. All right, we'll continue this in the next video.